Kia ora koutou. In this question, I'm going to go through two more questions from last week's Pure 3 exam. The first one's a differential equations problem, and the second one is quite an involved iterative methods one, which I picked on purpose because it made you draw some graphs and really explain what was going on. So in the first question, we're given a DE. This is it here. And the first thing we have to do is to show that when we differentiate tan squared of theta, that we get this. Then we're going to use that result, presumably, somewhere in the second half of the question. And there were a bunch of you who didn't realise that this was massively helpful in this second part of the question. Right? So that's how these problems are usually structured. There's usually a little bit of a clue to start with, and that leads you into the harder part. Right? So let's just start off by differentiating tan squared theta. So we've got a function squared, so it's going to be 2 times tan theta times the derivative of the inside function, which is tan theta. So that's 2 tan theta times sec squared theta, and that equals 2 tan theta divided by cos squared theta as required. So that's all there was to it. But what that means is that when we're getting this in our integral, we know that it is going to integrate back to tan squared of theta. So let's now look at the DE. Here it is here. We're going to have to start off by separating the variables. So I'll just work over here. So we've got x cos squared theta dx by d theta is equal to 2 tan theta plus 1. We want to keep everything with x's on one side and everything with theta on the other side. So looking at what's got x's in it, here's an x here and a dx here. And here we've got cos squared of theta and d theta. I'm going to start off by popping all of that into a big bracket. That leaves me with x dx is equal to, sorry guys, tan theta plus 1 divided by cos squared theta d theta. I promise that's all the sneezing I'll do down the laptop. Right, there we go. Now, let's split up the right-hand side and quickly integrate the left-hand side. So on the left-hand side, I've got 1/2 of x squared. You can put this plus c there, but I've chosen to put the plus c over here. And then splitting up this integral, you'll see straight away that I've got 2 tan theta over cos squared theta plus 1 over cos squared theta, which is simply sec squared theta d theta. Now, this is very easy to integrate, and this is easy because of what we've done in part 1. So we've got 1/2 of x squared is equal to tan squared theta plus tan theta plus c. The next thing I know from the question is that when theta is equal to pi on 4, we're told that x is equal to 1. So let's just go back up to the question and have a look at that, right? So we're not given the value of tan theta. We're given x is 1 when theta is pi on 4. But that means that I can substitute into here because tan of pi on 4 we know is equal to 1. So that gives me 1/2. Okay, so something weird just happened. Hopefully we didn't lose too much time, but we know that tan pi on 4 is equal to 1, and so now we can substitute in, and we get 1/2 of 1 squared is equal to 1 squared plus 1 plus c. So 1/2 is equal to 2 plus c, giving me c is equal to -3 on 2. Finishing off the DE, we've got 1/2 of x squared is equal to tan squared of theta plus tan theta minus 3 over 2. Okay, now what's left? We have to work out, what do we have to work out? Let's just go back to the question and have a look. Right, calculate the value of x when theta is equal to pi on 3 and give our answer to 3 significant figures. So we've done most of the hard work. Let's have a look. Right, so 1/2 of x squared is equal to, right, well, tan of pi on 3 is √3. So there's my wee triangle here. Pretend that's a right angle. Pi on 3 is here. All right, so tan of pi on 3 is √3. So √3 squared plus √3 minus 3 over 2. That gives me 1/2 of x squared is equal to 3 plus root 3 minus 3 over 2. So a half of x squared. I'm going really slowly here because it's better to go really slowly and not to screw up. That gives me x squared is equal to 3 plus 2 root 3. And x is going to equal what? Let's have a look. X is going to equal 3 plus 2 root 3. Now I just want to look at why I'm not using the negative root here. So let's go all the way back up to the start and just check. We are told that x is positive, right? So that's why I didn't bother with the negative root. But actually I should have said that. So in here, I think the first line should really be x is equal to plus or minus that. But x is greater than 0, so x is equal to the square root of 3 plus 2 root 3, and that equals 2.54. It is totally fine for you to go to decimals in this question because it's told you to go to 3 sig figs. I've just done it as an exact value because you know that I like them more. So in this case, if you wanted to, you could work yourself over to a decimal here using your calculator. Okay, so that's the first question done, and that's used up 6 minutes. Now, the next question is conceptually not that difficult, but there are a lot of bits that we have to work through. And the first thing we have to do is to draw a couple of graphs. I've left the space in here to do this. So I strongly recommend that you take your ruler in and you do the graph really thoroughly. There were a number of you who just chucked 2 marks away on this question. So we're going to start off by just thinking about what kind of bit of the graph we want to draw. And here, so let's get that there like that. And when I did this for my worked solutions, I counted off in centimetres where I wanted my points to be. So we know that e to the 2x is going to have a shape like that. And we know that e to the negative x looks roughly like this. And so 6 plus e to the negative x is going to have an asymptote up at 6. So we'll do 6 plus e to the negative x first. Here's the ruler. So let's put that in at 6. So that's an asymptote there. Trying to get the ruler to go away. Okay, OneNote's just glitched out again. Sorry, guys. Hopefully that'll come back. Yep, I've lost a little bit of time. So hopefully, I'm guessing you're just heading forward by 15 seconds on all of this and you're missing all of the fun. There we are. There's my asymptote at x equals 6. So points that I want to have on here is that I'm going to put on, so e squared is equal to, I don't know, 7 point something, blah, blah, blah. So we know that at 1, what do we know? So here, we're going to have 7 up here is going to be on the curve. And this one is not that steep, right? So this curve is coming in here like this, and it's going like that. We know that e to the 2x, on the other hand, is going to go through the point 1 here, and it's going to be very, very steep. So if we put in 1 out here, it's going to be up here, and it's going to look like this. You can see that one of them is increasing and one of them is decreasing. So this is my root here. We're going to label that as the root here, and we might just dot that down to my value down here. So that doesn't look that flash, and it's still missing a couple of important things, right? So the first important thing that it's missing is some labels. So this is x, and this is y, and this curve is y equals e to the 2x, and this one is y equals 6 plus e to the negative x, right? And we want to show that that's an asymptote there. We're also showing that we've got an asymptote here. That'll do. Right, so then we can say, we have to show that it has exactly one root, and we can say that it's due to the shape of the two graphs. We've got one decreasing and one increasing. The root shown is the only root. Now, the next thing says, verify by calculation that this root lies between 0.5 and 1. So I saw all kinds of kind of weird nonsense statements written here, right? What we need to do is we want to show that it's between 0.5 and 1. So we're going to do a little table like this. So here's x equals 0.5, and here's x equals 1. So here we've got e to the 2x, and here we've got 6 plus e to the negative x. So let's work out some values. Well, e to the 2x here is going to be e to the power of 1, so it'll be 2.718. 6 plus e to the negative x works out to be 6.607. This is less than this. At x equals 1, we have e squared, which is 7.389, and 6 plus e to the negative 1 is 6.368. Right, so some kind of really clear statement is a good thing to do here, right? So this is telling us something, but we need to explain what it says. Some of you, this is what I saw you write, and this was in more than one case. I saw you writing e to the 0.5 equals 6 plus e to the negative 0.5. Well, no, it doesn't equal it. That's the whole point, is that the root is not at 0.5. So just be careful that you're writing logical things. So now I'm going to write this. So since e to the 2x is greater than 6 plus e to the negative x at 0.5, and I mean, you could get away with this. The root is in between, and that's because both of the functions are continuous, right? So that's how we know that there is at least one root in between. Then the next part of the question was interesting, because what it's asking you to do is to show that if this sequence converges, then it's going to give us the right root for the equation in part 2. So we've got x, the n plus 1th value of x is equal to 1/3 times the log of this. The key to doing this question is to say, if it converges, then what that means is that this value is the same as this value. So we've got x n plus 1 is equal to xn, which is equal to my root x. So we can change this and this over to x and then rearrange. So we're going to have x is equal to 1/3 times the natural log of x of 1 plus 6e to the x. And then what I've got to do is rearrange it and get back to this. So that's my goal in here. Right? I want to get all the way back to there. And I'm showing that this formula is what will work for my iterations. So step 1 is that 3x is equal to this. Step 2 is to do e to the power of both sides. So I get e to the 3x is equal to 1 plus 6e to the negative x. I'm going to divide everything through, sorry, not 6e to the negative x, 6e to the x. I'm going to divide everything through by e to the x, because I'm looking up here and I want to have e to the 2x. Actually, because I'm doing a show that, I'm not going to go that fast. So we're going to have e to the 2x is equal to 1 over e to the x plus 6 e to the x over e to the x, which gives me e to the 2x is equal to e to the negative x plus 6 as required. So there we are, we're done with that one. Now the last part of the question, and I've got 1.5 minutes to do it, is the really boring part. First of all, the root ends up being 0.928. I had about 6 of you who rounded this number and you got 0.927. That made me sad, right? So don't do that. Do your rounding properly. And you were asked for 3 decimal places or 3 sig fig, I think. So again, a table is a really good way to go. You don't have to show over and over that you're using the formula, but you need to show it a couple of times. So I started between 0.5 and 0.1. I just started at 0.8. And actually it converged really slowly, which was kind of annoying. We got this, and then we're going to write that value out. And they want us to go to at least 5 dp. And so then I'm going to do that twice over, just showing what's going on with the updating. And then from there, all I did is I just wrote down my lists of values. So I got this, and it took forever. So what I'm looking for is convergence to 3 sig fig, and I haven't found it yet. And I still haven't found it. I could make a bad U2 song joke here, but I won't, because no one's going to laugh. There we go. Finally got convergence. So my root is x equals 0.928 to 3 dp. Thanks for watching. I'll do more later on.